afternoon. Welcome to my session, SaaSFi in Orbit, where we'll be analyzing government innovation investments using AI. Dan said, my name is Kelsey. I've worked with the federal government for my entire career, and I've always used SaaS. Deep down to my core, I'm a SaaS programmer. But the power of SaaSFi and the platform really allows to take your coding way beyond the ends of the earth. And so I hope to prove that to you all today with some text modeling and visualizations using the SaaSFi platform. You may have heard Brian Harris talking about the Artemis II mission this morning, and it's really an inspiring event, kind of cultural event for all ages. It's my kids' current hyperfixation, which I'm not mad about at all, but they love watching all of the coverage. The launch, the astronauts floating through space, the Nutella jars floating through space. And if you don't know what I'm talking about, check out some of the Artemis II coverage. But they cheer when the parachutes go off during the landing, and then they scream when the astronauts make their safe splashdown into the ocean. Like all kids and like young kids, they ask me a million questions that I don't know the answers to. They're like, Mom, why is the rocket on fire? How did they get up there? Why are they floating? Why is her hair going all crazy? And through their many questions, I'm reminded that behind these space missions, there's an enormous amount of research and investment happening many, many years before liftoff. So taking my mom hat off and putting my analytics hat on, it got me thinking, how does the government know we're investing in the right technologies that make these missions possible? And with diminishing budgets, at least for the United States federal government, how do we even know where to invest or if research has already been done somewhere else? And not just about the rockets and the propulsion, but everything that goes into it, the propulsion, the avionics, and launch systems. So strap in today because we're going to take our own analytics mission using public data, SAS Visual Text Analytics for some modeling, SAS Visual Analytics for some reporting, and we're going to use David Vike's AI Accelerator framework to explore where space-related research dollars are going for the US federal government. Every mission needs fuel, and for every analytics project, we need data. And so for our project, we're going to use mainly one data source, small business innovation research and small business technology transfer, contract award data. I'm going to just refer to this as SBIR and the SBIR program for the rest of the presentation. This is a program out of the Small Business Administration intended to fund technology research, everything from prototype and development all the way through technology commercialization. And then they make their data open to the public, so it's super easy to use. Starting on the left-hand side, it has structured fields like contract award titles, the names of the private companies who are submitting these contracts and being awarded through the SBIR program, the federal agencies who are funding the contract through the SBIR program, proposal and contract dates, contract phases, which correlate to the sophistication of the research, and also the dollar amounts, the funding amounts. But it doesn't have any structured categories about the actual research itself. So we can't easily quantify things like how much money is the government spending on, let's say, avionics research. But it does have this large research abstract all the way to the right that you see. And this unstructured text is where we're going to derive some of our new insights and perform a lot of our analysis today. So we need to set our mission course. Like the Artemis series missions, we're not just going to start with landing on Mars. It's got to build incrementally. So in our case, we can't just completely optimize government spending from the start. So for today, our mission and our goal is going to see if we can derive insight on this data source and answer questions like what technology domains are being researched by who and how much are we spending on that research. And understanding and quantifying the research is where the text analytics piece comes in. So we took the research abstracts from SBIR related to space, and we tokenized them by sentence. And so sentence tokenization is a well-proven pre-processing recommendation from our SAS text analytics experts, Tom Sabo and Mary Osborne, and I collaborated with Tom on this project. We used these sentences and developed a text model with two different layers. We looked for some unsupervised technology domains. These were things that were naturally emerging from the data, and then some supervised technology domains. based on a space launch taxonomy or list of terms relating to space and launch. I'm not going to go deep into the text analytics model for this presentation, so if you're hungry for even more text analytics, you should definitely visit Tom and Mary in the NLP booth today. We scored the research abstracts at the sentence level using our visual text analytics model to enrich the data with the technology domains that we derived from the abstracts. Remember, these technology domains did not exist in the original data. So this gives us something that we didn't have before, an explorable view of the research topics and the technology domains. So we put that enriched data into a visual analytics report. We also added some data from usaspending.gov, which is another data source for federal funding, and just to supplement some of the structured contract data to create a complete funding picture beyond the SBIR program. And then using the SAS AI Accelerator framework, which is a free framework project to help you build and deploy AI agents within the SAS Viya platform, we embedded a really helpful summarizer agent that makes ad hoc calls to large language models to help summarize some of the research abstracts by technology domain for us. Okay, so we have our public data as our fuel. We have our mission course. Let's take SAS Viya into orbit. We're going to start with a 30,000-mile overview. On the right-hand side, in the pie chart, we can see we're working with about 3,000 space-related contracts, 2/3 of them being phase 1 research, and then just above it in the line chart, if you can see, it's over 25 years worth of data. On the left-hand side, the vertical bar chart, you'll see the unsupervised categories. These were the technology domains that naturally emerged from the data. We didn't go looking for them. And we can start to see some of the dominant research themes and compare average awards amounts. For example, over the last 25 years, the contracts performing research related to missile threat had the highest average award amounts. Well, let's say we want to look at just the last 5 years, because technology is rapidly changing, as we know. And we can see within the last 5 years that the contracts conducting research related to hypersonic flight and missile detection received higher average funding amounts than the missile threats we saw before. So remember, these technology domains are a result of our text analytics model. So this simple level of analysis could not be done on this data without using our text analytics model. We can also start to evaluate and understand research priorities by different government agencies. So let's pretend I work for NASA and I'm aware of the research that we fund. Ooh, sorry if that was a big bonk. I just touched the mic. We have, let's say I'm from NASA, I'm aware of the research that NASA funds, but maybe I have little insight into what defense is investing in. I can drill down on the DoD and see that the Air Force is actually funding the majority of the SBIR space-related contracts for the DoD. And their average award amount is highest for research pertaining to unmanned aircraft systems. So let's say at NASA, we have a critical need for new emerging technology with regards to unmanned aircraft systems. Maybe we can leverage research that the Air Force has already done or already invested in. Again, something I couldn't know before without using my text analytics model and putting it in a visualization like this. Let's take a look now into some of the supervised technology domains. Lunar concepts, spacecraft systems, and cislunar concepts. These were domains that we explicitly went searching for in the SBIR contracts using our space taxonomy within visual analytics. And with the Artemis spacecraft missions, images like basically burned into my brain with how often my kids are watching the launch and all that stuff, I wanted to learn more about the spacecraft system, so maybe I'll be able to answer some of their hard questions next time we're watching it. So we're going to drill into that one. And we're going to move from our overview tab to a report that is a little bit more detailed on the spacecraft systems research. And so now on this view, we can start to analyze the terms from our space taxonomy in the context of spacecraft systems research. So of those 3,000 original contracts, a little over 200 are conducting research related to spacecraft systems. And of those, a lot were awarded to companies located in California. And by selecting California on the map, I can view exactly which government agency and what research is being funded there by the government. And if you work with government agencies, they get many inquiries, at least in the US, from Congress, they're wanting to know how government money is going and investing and supporting businesses within their state or their congressional district. So including this kind of geographic element to analyze the data here allows me to say to someone coming with me with an inquiry to say, hey, here's how much we're spending in your state specifically for research related to, in this case, spacecraft systems. Again, without our text analytics model, not a question that we could easily answer before using this particular set of data. And we can actually go one level deeper than just, hey, you're doing research on spacecraft systems by using our tree map of terms that's on the right-hand side. And it shows us the specific technology terms found in the research abstracts in the context of spacecraft systems. So the size of the rectangle indicates the number of contracts that perform research on that technology. And then the darker the blue-gray color is indicates the higher average award amount. So in this case, avionics is the largest rectangle, meaning it has the most contextual mentions in the research abstracts, but payload systems is the darkest, meaning the research using payloads on or using payload systems have the highest contract funding on average. And so just scanning some of the terms within the tree map, I thought laser beam propulsion sounded really cool. It reminds me of lightsabers, and Star Wars is another hyperfixation for my kids right now. So I'm gonna click on that. And so I can see there's a total of 4 contracts funded by the SBIR for research on laser beam propulsion within the context of spacecraft systems. And then 2 of those contracts are performed in California, or done by companies who are located in California. And if I double click again on the laser beam propulsion in the tree map, it will send me to a sentence level detail mentions of the research abstracts of laser beam propulsion. So I'll show you what I mean by a second. So I'm going to double click on the box within laser beam propulsion. And here it takes me to the sentence level data of those 4 contracts that we saw before. I see that the one company on the top there, X Quadrum, has 2 contracts, and they're the ones that are located in California. They had a contract that was phase 1 and another that was phase 2. You can kind of see the difference in the funding between the phase 1 and the phase 2 contracts. If you start to scan some of the sentences, you'll notice that the contract actually mentions using laser beam propulsion as a cost reduction, specifically for microsatellites. So now we only have 4 sentences here. It's easy for us to read, but we could apply this text analytics model to an entire database of research findings or very technical papers that could be very, very dense, which could be thousands and thousands of pages and sentences to comb through. And so before I start to review and reading all these technical findings, maybe I want to create some sort of summary on it using a large language model. So I can go to my summary agent directly within my SAS Viya Visual Analytics report and generate a summary on the fly for me using those 4 sentences as my input. And it's creating the nice summary for me. This particular aspect of the tool and of the report is using David Vike's AI Accelerator framework. And we're integrating generative AI large language models. I'm using here ChatGPT 5 Mini, but it's right within my visual analytics report. And this is so cool to me as someone who works a lot in visual analytics. And if you think it's cool too, you should definitely try and hit the Agentic AI booth. And if you can find David, he can probably show you even more sophisticated and complex examples of this. Okay, so what does it tell me? The LLM tells me that the research around laser beam propulsion is often mentioned to reduce costs for specifically microsatellites. So because the number of sentences we were looking at before was so small, I can easily verify that this LLM is not having any hallucinations, which is kind of nice to validate. But we found with larger amounts of text, using SAS text analytics and traditional NLP techniques to filter on relevant subsets of text to large language models actually does help reduce hallucinations and produces more relevant results. So I really love being able to use the output from our SAS text analytics model, filter on something relevant that I'm interested in this case it was laser beam propulsions, and pass just those directly through to an LLM. And using the AI Accelerator framework, it's helping me do that directly within the Viya platform, which is really, really nice for me as someone who's developing some of this content. Let's go back to the sentence level detail. The last contract at the bottom done by Physical Sciences is missing some key date fields So maybe now I want to investigate a little bit more on this company because I'm missing some of the data here, or I want to just understand all of the research that this particular company has been awarded through this program. So I'm going to go back to our main page. And now I'm going to switch from a technology topic focus to a more awarded company focus. So first, I'm going to search by the company name here. So I'm starting to type in physical sciences. And I can begin to explore the contracts awarded to physical sciences through this SBIR program, which are quite a lot. 44 contracts. They're funded by both the DoD and NASA. Over $17 million worth of money spent just through this SBIR program. They're kind of a mid-sized company with about 11,000 employees. I can start to review their individual contracts to kind of see what the company specializes in. But with 44 contracts, maybe I want to feed these abstracts into my summarizer agent to get an understanding of what the company specializes in and of this company's works and this company's work through the SBIR program. And up until now, we've only been looking at the data through the SBIR program. But maybe we want to look at contracts for this particular company outside of SBIR. So that's where we're going to bring in the USA spending contract data. And if I'm looking at it now, here's a list of all of their contracts that's housed within USA spending. And you can see they have dozens and dozens of contracts, some with 8-figure dollar amounts obligated by the DoD. So they must be doing some very sophisticated or some very important work. And again, I can feed these contracts now into my summarizer agent and get a summary of the work that they're doing outside of the SBIR program as well. So again, let's pretend I'm working for NASA, and I identify this company as something that they're specializing in through this report here. I can maybe then go speak with them for missions and priorities after the Artemis series missions. And my helpful analysis through this entire dashboard kind of led me right to them. I'm just kind of visually exploring it. So I'm going to pause. We've gone through a lot. We're going to review a little bit and then bring it back down to earth. We began using our public data sources and our output from our text analytics model. We were able to identify over time how different agencies were investing in different space-related research. We drilled down to the sentence level to understand the exact research that the government was funding. We used large language models to generate summaries for us on the fly. We focused on a particular company to try and understand what they specialize in different space-related domains. And we did this all within the SAS Viya platform. So I would say that our analytics mission today has been a success. And thank you so much for joining me on this journey. I'd love to open it up now for questions or discussions and hear a little bit more about how you're using the SAS Viya platform. Does anyone have access to SAS Viya?
All right.
Yeah.
Before we get into questions, just a quick round of applause for Kelsey. Thank you, Kelsey. All right, and if you've got some questions, I'll come around with the microphone and you can fire away. Any questions? You guys are still in orbit? Is that what's going on?
Takes a while to acclimate, yeah, with the gravity. Yeah.
Thank you very much. That was awesome. We've seen a lot of instances of the AI accelerator and Copilot being introduced in platforms like Visual Analytics. Mm-hmm. Curious what the timeline looks like for those to be available to us. Are some of those available now, especially if we're on like a long-term stable version, for example?
I would have to double check our documentation pages for those specific things, and we would have to cross-check with whatever version that you're working with. But the AI accelerator, it's a project that David Vike has been working on. I integrated this. I don't think there's any limitation on the version of your platform. You do need intelligent decisioning, which is a component of the platform. So that's kind of what the job is happening behind the scenes that I embedded into the Visual Analytics report. So I think Viya Copilot is out, but Don't quote me on the release dates because it's so hard to keep track of everything. I would want to double check the documentation pages. That was a great question. It is a lot and overwhelming with all the different AI components that are coming out, the capabilities that we have.
Thank you so much. Any other questions? Yes, sir.
Do you also integrate with the grants?
We could ingest grant data, absolutely. This was just a different type of contracting data source, but we could absolutely be looking at grants data as well here. Yeah, especially if there's the unstructured component to it. There's so much rich information kind of buried in there. And so using the text analytics to kind of extract that and then using the Gen AI on top of it to summarize it and make it more actionable or usable, especially when you're working with a lot of data, to me is really, really powerful and very exciting. Great question.
Excellent, thank you. We've got time for a few more questions, if anyone has any questions. Going once, going twice. All right, well then that concludes this session. Thank you again, Kelsey. And thank you for attending and have a great rest of the day.